Let us calculate the moment of inertia of a solid sphere. And again, as solid sphere is a rigid body, we cannot directly evaluate it. We need to first consider small elements in the sphere, integrating which we find the total moment of inertia. And for a solid sphere, let us consider a hollow spherical element which is of radius x and its wall thickness is dx within the volume of the solid sphere. So there is a hollow sphere which is of radius x and its width is wall thickness or width of the wall is dx. In this situation, we can find out mass of element dm to be mass per unit volume multiplied by the volume occupied by the elemental shell. So here total mass is m divided by the total volume, which can be written as 4 by 3 pi r cube multiplied by the volume occupied by the hollow spherical shell, which we can calculate by multiplying its surface area and the width. So surface area of the shell can be written as 4 pi x square and width is dx. So this would be the mass of the element. Here 4 pi can be cancelled. So here value of this dm can be written as 3m by r cube into x square dx. If this is the elemental mass dm, which is that of a hollow spherical shell which is of radius x, we can find out moment of inertia of the element is this di. We already calculated in the previous article that for a hollow spherical shell, the moment of inertia can be written as 2 by 3 mr square. So in this situation, this di will be 2 by 3 dm x square because the mass of this elemental shell is dm and the radius is x. We substitute the value of dm. Here di can be given as 2 by 3. We substitute dm, it is 3m by r cube into x square dx multiplied by x square. Here 3 also gets cancelled out. Di we can write it as 2m by r cube into x4 dx. So total moment of inertia of solid sphere can now be directly given by integrating this di. And here as 2m by r cube is a constant, we can keep the constants out of sign of integration. It is x4 dx. And the limits of x we substitute from 0 to r. So the integration of x to power 4 can be given as x5 by 5. So it can be written as 2m by r cube into r to power 5 by 5. So here this r cube gets cancelled out with the 3 powers of power 5. So the result will be having is 2 by 5 mr square. This is the result for moment of inertia of a solid sphere rotating about an axis of rotation which is passing through its center.